Question 17. These statements are about the activation energy of a chemical reaction. The first statement states that the chemical reaction in gases and liquids take place when molecules collide with sufficient energy to overcome the activation energy. This statement is correct. For a chemical reaction to be successful, the activation energy has to be overcome. If we were to draw an energy profile diagram of a reaction, starting with the reactants on the left, ending up with the products, the activation energy is the height of this hump and can be thought of as a barrier. So the activation energy if seen as a barrier needs to be overcome in order for a chemical reaction to occur. Statement 2 states that if the activation energy for a reaction is high, many of the collisions have enough energy to be successful and the reaction is fast. The activation energy for a reaction, if thought of as a barrier, being high means that many of the collisions will not have enough energy to be successful, because now the barrier or the obstacle is more difficult to overcome. As a result, the reaction will be slow. Hence, statement 2 is wrong. A catalyst reduces the activation energy for a reaction, and therefore the overall enthalpy change of the reaction is lower. The first part of this statement is correct, where the catalyst can reduce the activation energy of a reaction. This can be seen from a smaller hump on the energy profile diagram. However, the overall enthalpy change of the reaction is going to be the change in energy from the reactants to the products. The overall enthalpy change is independent of the value of the activation energy. In the same reaction, with or without the catalyst, the reactants and the products are the same. Hence, the overall enthalpy change will remain the same. Therefore, the second part of statement 3 will be wrong. That leaves us with option A as the correct answer.